All right, so yesterday we did products of powers properties. Today we are going to do the quotient of powers property, okay? So basically it just says to divide powers with the same base. Once again, it has to have that same base. Like, for example, 4 is the same base. All you have to do is subtract the exponents, okay? So 4 to the 5th divided by 4 to the 2nd is 4 to the 5 minus 2, which is 4 to the 3rd, okay? And a cannot be 0 on these. So example 1, 2 to the 6th divided by 2 to the 4th. The first thing I need to check is that the bases are the same. And since they are, I can proceed. So this is 2 to the 6th minus 4, which would be 2 squared. Same thing with B, -7 and -7. My bases are the same. So all I would do would be -7 to the 9 minus 3. You would subtract. And this would be -7 to the 6th power. C, bases are the same, so I can't subtract. H to the 7 minus 6 is h to the first power, or you can just say h. And that's it for example 1. Try these 4 on your own. I'm going to leave these up here so you can see the examples. Remember, when the bases are the same, you can subtract their exponents. So go ahead and hit pause, and when you're ready, you can hit play and check your answers. Number 1, base is the same, so I do 9 to the 7 minus 4, which is 9 to the 3rd power. And number 2, I have 4.2 and 4.2 as my base. So then you do 6 minus 5, which is 4.2 to the first power, which you can just write as 4.2. Number 3, my bases are the same. I have -8 to the 8 minus 4, which is -8 to the 4th power. And number 4, bases are the same, so I have x to the 8 minus 3, which is x to the 5th power. So pretty simple. Example 2, we get a little bit more complicated when we have to add some steps in here. So now we need to simplify our expression, and we need to use what we learned yesterday as well. So the first thing I see, I'm going to rewrite this down here. So 3 to the 4th times 3 to the 2nd over 3 to the 3rd. First thing I see is products of power that we learned yesterday. I have the same base, so I'm going to rewrite that as 3 to the... Sorry, I'm going to rewrite this as 3 to the 4 plus 2 over 3 cubed. So now this is 3 to the 6th over 3 to the 3rd, and now I have my quotients property, which is 3 to the 6 minus 3, which is 3 to the 3rd power as my final answer. Example 3, I need to simplify this expression. I'm going to rewrite it again so I don't confuse myself. So I have a to the 10th. Where'd it go? Oh my gosh. A to the 10th over a to the 6th times a to the 7th over a to the 4th. So I'm going to start with this. So I have a to the 10th over a to the 6th. That's the same thing as a to the 10 minus 6, which is a to the 4th. Same thing here. I can write that as a to the 7 minus 4, which is a to the 3rd. So I have a to the 4th times a to the 3rd. Bases are the same, so I add their exponents, and I have a to the 4 plus 3, which is equal to a to the 7th power. And that's how you do example number 3. You have 3 on your own to do. Please try these. Pause the video on your own and hit play when you're ready. So number 5, I need to mess with the denominator first. So I have 2 to the 15. My bases are the same, so I can add my exponents. So I have 2 to the 15 over 2 to the 3 plus 5, which is the same as 2 to the 15 over 2 to the 8. And now that I see division, I subtract. So now it's 2 to the 15 minus 8, which is equal to 2 to the 7th power for number 5. Number 6, I'm going to start with this one first. Remember, if there's no exponent, the exponent is 1. So this is d to the 5 minus 1, which is d to the 4th, times d to the 9 minus 8, which is d to the 1st. Now I have the same powers, or excuse me, the same base. So I can add my powers. So it's d to the 4 plus 1, which is d to the 5th power. Same thing on number 7. I'm going to start with this one. I see a division problem, so I know I use my subtraction. So it's 5 to the 9 minus 4, which is 5 to the 5th, times 5 to the 5 minus 2, which is 3. Once again, I see my same powers, or excuse me, same base, so I add their power, so it's 5 to the 5 plus 3, which gives me 5 to the 8th power. It's not hard, it's just a lot of rules you have to remember. And example 4, my real life applications. So the projected population of Tennessee in 2030 is about 5 times 5.9 to the 8th power. Predict the average number of people per square mile in 2030. So I gave you a little hint here. This is the model we need to use. So people per square mile is what we're trying to find. So the population in 2030, I told you, was 5 times 5.9 to the 8th power. And the land area is 5.9 to the 6th power. And I found that by using this over here. Okay, so I'm going to rewrite this because it looks kind of funky. So I'm going to rewrite it as 5 times 5.9 to the 8th over 5.9 to the 6th power. Just getting that 5 out of there. And then I see my quotient powers of property, so I know I need to subtract these two exponents. So I have 5 times 5.9 to the 8 minus 6, which is to the 2nd power. And this I actually do want you to put in your calculator. So you have 5 times 5.9 to the 2nd power, and that gives you 174.05. And so that's approximately 174 people per square mile. I'm just going to say a mile squared. And I think that's it. See you tomorrow.